This is a lesson on similar figures. This is part 2 where we're finding the missing length. We're going to prove that two figures are similar by using proportional reasoning to find the missing length. So we've talked about figures being similar if they are proportional to each other. We can create a proportion using corresponding sides, and if they are congruent to each other, the proportion, then those two figures are similar to each other. Well, what happens though when we don't have all of the information? We don't know all of the sides. That's what we're going to look at today. We want to prove that the two shapes that we're looking at can be similar or not similar. We're going to prove it by using proportional problem solving. Okay? So remember, for two shapes to be considered similar, there are two requirements. The first requirement is that the angles are congruent with each other. So let's take a look at our angles. If the angles are congruent to each other, the corresponding angles, that's part 1. So we see that they both have a right angle, so that's good. And this angle up here in this corner says it's 55 degrees. So if it's 55 degrees, then that would mean that this angle over here is 55 degrees. And it didn't tell us, but we're going to assume that B is going to be 55 degrees because similar shapes have congruent angles. And then going back to our large shape, we see that this angle over here is 35 degrees. Therefore, A, the value of A, this corner, would also be 35 degrees. And if we added up all of the corners, the 3 corners of our triangle, they would equal, that's right, 180 degrees. So again, part 1 is that all angles have to be congruent to each other. And in this case, they are. So the second step in proving that shapes are similar to each other is by using proportional reasoning for corresponding sides. So we want to see, are our sides proportional to each other? So we're going to compare. I'm going to say that this is our big shape and this is our small shape. So we're going to compare our big shape to our small shape, set up our proportion. And I'm going to go ahead and start with what we know. We know that 45 corresponds to 9. So 45 corresponds to side that is 9. And now we want to find a side that has a missing length. So we can either use this top side right here. We can use this side, or we could use this bottom side. I'm going to go ahead and look for shape for side D. I want to figure out what D is. So that's our missing part. So we want D, and it corresponds on the other side with, it corresponds with the value of 20. So now what we have to do to find the value of D is we're going to cross multiply. So we'll cross multiply 45 times 20, and then we're going to divide by the number that's left over, which is 9. Okay, so on your calculator, let's go ahead and figure this out. 45 times 20 equals 900, and then when we divide by 9, we get that the value of D, so the value of D is going to be equal to 100. Okay, very interesting. Go ahead and pause the video and copy the definition, the work, and the shapes, all of this information that you see on the screen, into your math notebook. All right, let's try a few more examples. Here we have 2 more triangles, and we want to use proportional reasoning to find the missing value. So again, this can be tricky because our shapes, the orientation, the way that the shapes are shown to us is different. That we have one that's turned around, and so if we look, this shape right here has been turned slightly, but they did give us important information that can be helpful to us. if we look at this right angle right there, and we see that the opposite side is right there, and if we were to take this shape right here, the smaller shape, and if we could rotate it backwards just a little bit, we would see that we could create another triangle that looked like this, and this would be our X, and this would be Z, and this would be Y over here, okay? And then our X, our little X would be right here, and 20 would be down here. If that helps to rewrite the orientation of the shapes so you can see them easier, you are always welcome to do that. So let's see, how would we set this up? So we need to decide who we are comparing. If we're doing proportional reasoning, we always want to start with what are we comparing with each other. So in this case, we're comparing our big shape to our small shape. And let's go ahead and identify. We're going to say this is our big shape, this is our small shape. All right, so let's go ahead and set up the proportion based off, always start with the one ratio that you know, and then the second ratio is the one that you're trying to find out. Okay, let's see. If you did it, then you got, let me get this out of the way, you got 45 is to 20, or I'm sorry, 40 is to 20, and then on the, that's one that's known, and the missing part is 50 over X. So now we want to go ahead and solve it. So go ahead and get out your calculator, and we're going to cross multiply. So you're going to multiply your opposite values, just like with our proportional reasoning unit. And you're going to divide by the number that's left over, divide by that number. And what is the value of X? In this case, the value of X is 25. Very good. Let's try another one. Here we have, again, two triangles. And this time, one of our triangles has a decimal in it, and that's fine. We can always solve exactly the same way with a decimal number or a whole number. Doesn't seem to matter. That's good to go. Let's identify who our corresponding sides are so we can make sure that we have our part straight. So the long diagonal line right here, this yellow line is going to correspond to this yellow line over here. Let me choose a different color. All right, and then I want to go from B to C. And B to C, that segment corresponds to Z to Y. Very good. And I'm going to go ahead and use this blue. And this line segment from A to B now corresponds with X to Y. Remember, when we are identifying our corresponding parts, we always want to make sure that we are identifying them in the correct order. For instance, angle A, or the top of this line segment, corresponds to angle X. So I wouldn't want to say A to B is corresponding to Y to X, because A does not correspond to Y. All right, so now that we've identified the corresponding sides, it makes it a little bit easier to set up our proportion. I encourage you to use colored pencils or crayons or markers as you're doing this unit. It makes that so much easier to solve. Okay, so again, what are we comparing? That's right, we're comparing our big to our small shape. So who's big? This is our big guy, and this would be our small shape. Okay, I did not turn this second shape around, but I'm hoping because we color coded the sides that will make some sense to you. Now we want to set up our proportion. So start with the ratio that you know, and the second ratio would be the one that you're trying to find. Then we have a few options here. All right, so I set it up to be 14.4 corresponds with 12, and X corresponds with 13. Excellent. All right, so again, you're going to cross multiply the numbers you have, and then you will divide by the number that's left over to find the value of x. And after you do so with your calculator, you're going to find that x is equal to 15.6. All right, that seems like it will make sense because we already have 14.4 as one of our values. So to have another side that is a decimal doesn't seem to be out of sorts in this situation. Let's go to our next example. Here we have two rectangles. Again, we want to use proportional reasoning to find the missing value. Now we know with rectangles that we have opposite sides are congruent to each other. So this side is congruent to this side, and it corresponds to these two sides as well, doesn't it? Excellent. And then I'm going to use my magenta color, and then the two shorter sides, our two widths, are congruent to each other, and they correspond then to those sides as well. All right, so we want to identify who we are comparing. We have our big shape to our small shape. All righty, so then we set up that information that helps us know where to set up our numbers. And now looking at the values that are given to us, we want to set up our proportion. So again, our big shape is on top, small shape's on bottom, and it would look like this. 18 over 12 that's our known parts. Those two values are known. And then we're looking for 120, and it corresponds to x. And once you cross multiply these two numbers and divide by the number that's left over. And then what is x going to be worth with our calculator? Hopefully you're doing the problem along with me on your own for practice. You're going to get that x is equal to 80. Very good. All right, we have one more example to talk about. We have this one. It kind of looks like a slice of pizza. And believe it or not, there are two shapes here, and we're hoping to see that they're similar to each other. So in this case, we have a large triangle. I'm going to trace over that large triangle. And then if you can notice, we have a smaller triangle laying on top of that the large triangle. So a large one on top of a small one on top of the large one. I've always encouraged everyone to separate the shapes, draw them as two separate shapes so you can easily see where the sides are and set up your proportion. So let's go ahead and do that. Here we go. What I've done is I've taken the large shape, A, B, C, as our triangle, A, B, C, and I've drawn it out over here, and I've included all of the parts. And in this case, I'm going to just say that I'm going to assume that x is going to be the whole value from A to C. I'm not entirely sure for this example, but that's what we're going to go with, okay? And then I took the smaller shape, D, E, C, and drew the smaller shape, and then wrote down the values that I know. So now I've taken this layered shape and taken it into two separate shapes. Okay, and I'm going to go ahead and set up the information. So setting up the proportion, I'm going to say that big shape to small shape, we have 11 over 7 is the known. The unknown is x over 15. And when we solve it by cross multiplying, you're going to find then that x is going to be equal to 23.6 in this case. All right. Well, hopefully those examples helped you. Now it's your turn. I want you to copy these shapes into your notebook, show all of your work to find the missing value to prove that the shapes are similar to each other. Number 3 is a word problem. So read it and draw out the shape and then solve it. And 4, just straight out pictures, solve, set up your proportion, and solve. I'll see you next time.